Yeah, welcome to Phenomath page. In today's lesson, we're going to talk about enlargement and similarities. But for today, I'll be talking about enlargement, and in the next video, we'll talk about similarities. So this is going to be the part 1, and the part 2 will be the next video. Stay focused and tuned for the next video as well. Now let's begin. Now from this setup, you can see that the triangle A1, B1, C1 is an enlargement of the triangle ABC. That means that we've increased the size of the triangle ABC to obtain the triangle A1, B1, C1 by a certain scale factor K. The scale factor, which is denoted by the letter K, is the number that indicates how much a shape is increased or decreased. Increase, that means we're talking about enlargement, and decrease, then we're talking about reduction. So the scale factor can increase an object, it can also decrease an object, depending on the number that we are using. Now let's see something. The scale factor has a formula, that is the scale factor K is equal to the length of image over corresponding length of object. So when we are given two shapes whereby one of them is an image of the other, that is when we can use this particular formula. So what we have here is a typical example. This is the image of this one. So we can use this formula to find the scale factor, that is K. The scale factor is equal to the length of image over corresponding length of the object. Now let's make some deduction from this formula. Scale factor is equal to length of image over corresponding length of object. We can make length of image the subject. So we make the length of image the subject, we just have to multiply the scale factor K by the corresponding length of object. That is what we have here. So if you want to get the length of image, just multiply the scale factor by the object length. Now, this means that the scale factor plays an important role here. When the scale factor is greater than 1, then we are going to have an enlargement. For example, let's take the scale factor to be, let's say, 2. If that happens, it means to get the image, we have to double the object length. And that will give us an enlargement. But when the scale factor is, let's say, half, that is between 0 and 1, I want to use half for that one. In that case, if you want to get the length, the image length, you have to have the object length. And that will obviously lead to, reduction. So when the scale factor is greater than 1, we have enlargement. When it is between 0 and 1, then we have reduction. So let's take note of that. Now, from this, anytime an object and its image are given, we can find the scale factor using any of the corresponding, side, the ratio of the corresponding sides to find the scale factor. So in this case, I can use, A sub 1, B sub 1, and that of AB to find the scale factor. So the scale factor K can be found using A sub 1 divided by AB to get the scale factor. It is also the same as using, let's say, B sub 1, C sub 1 divided by BC, which is also the same as using A sub 1, C sub 1 divided by AC. So all these can be used to find, the scale factor, which is K. So when we ask you to find the scale factor, just use, one set of corresponding side and, find the scale factor. You can't use all of them because you end up getting the same thing. Now let's use this idea to work some questions. So let's get our first question. The diagram below, A1, B1, C1, D1, that is this shape, is an enlargement of this ABCD. So that's the image. So this is the image. So we have the image here, and this is going to be the object. We have enlarged this one to get this one. Now AD is equal to 12 centimeters. So let's get right here. So AD is 12 centimeters here. DC is 8 centimeters. So we have 8 centimeters. And A1, D1 is 36. A1, D1, that is the side of the image. That's going to be 36. And we have to find D1, C1. So you're looking for this side. That is the side that we are looking for. So what do? We're going to use this formula to find the scale factor. That's the length of image over corresponding length of object. So now, let's say something here. To find the scale factor, which is K, we are going to use suitable pair that can be used to find the scale factor. So in this case, I can use, A1, D1, and that of, AD. The reason is that their magnitudes have been given. So we have 36 for A1, D1, that of AD, 12 centimeters. But the other sides, we can't use because some of the magnitudes are missing. So in this case, I can use this one. So A1, D1, that's going to be 36 centimeters. and it is out of 12 centimeters. We can just cancel out, 12 here, 1, it goes into 36 3 times. Remember, the units will just cancel out. The scale factor has no unit. So the scale factor, which is k, is going to be 3. So that is how we can find the scale factor for this, enlargement. Now, after finding the scale factor, how do we find the side D1, C1? And that is what the question is demanding. We know that whenever we get the scale factor, we can just multiply by the object length to get the image length. So we can say that D1, C1, which is the image length, is equal to, K times the object length, which is DC. Now we know that K is 3, and DC from the question is 8 centimeters. So that's going to be 8 here. Now when you multiply, you're going to get 24 centimeters. So that is how we can find, DC in this case. Now we can use a different way to, get DC. So let me use that one here. We can set up equivalent ratios here or equal ratios here. Now we know that A1, D1 out of AD, these sides are corresponding, and it is equal to, D1, C1 out of DC. Now I've used this because that's the side I'm looking for, D1, C1. Now A1, D1 has been given, that is 36 centimeters, and AD is 12 centimeters, and that is equal to D1, C1 out of DC has been given already to be 8 centimeters. So you can set up your equation like this, and now you simplify. 12 here, 1, it goes into 36, 3 times. So you're going to get 3 equal to D1, C1, that is what we are looking for, out of 8. Remember that 3 is also out of 1, so we can do cross multiplications. So when you do that, you're going to get D1, C1 times 1, and that will give us the magnitude of D1, C1, and it is equal to 8 times 3. That is equal to 24 centimeters. So you can also use this approach to find the magnitude of D1, C1. Or you use the first method, you just have to find the scale factor, then multiply by the object length to get the image length. Let's get this question. Triangle ABC is an enlargement of triangle CDE. So that's the triangle. ABC is the bigger one. ABC, that's the bigger one. So that's going to be the image, because that's the enlargement of triangle CDE. So that's the object. If AB is parallel to DE, they are parallel lines, AB and that of DE. And the area of triangle CDE is 78 centimeters square. So that's the area of the smaller triangle. We have to find the scale factor, that is I, the value of X, that is II, and then the area of the triangle ABC, that's the bigger triangle. So let's begin. So anytime we get diagrams like this, whereby the image and the objects are, merged, it is better to withdraw them, by separating the triangles or the shapes. So here I've separated them. One is going to be the object and the other will be the image. And from the question, we know that, CDE is the object. So that's a smaller one. So let's make this one CDE. So here's going to be E. Here will be D, and here is going to be C. So that's a smaller triangle, and there's the object. Now when you come to the image, we have CAB or ABC. So here's going to be A, here's B, and here's going to be C. So these are the vertices of the triangles. Now let's get the size. DC has been given the question, and that is 14. So here's going to be 14 centimeters. Which one else? We have ED, that is 18. So that's going to be 18 centimeters here. And then we have X, that is AB. So here is XAB on the image. And we have, BC. BC on this side is the same as, 14 plus 21. So if you want to get BC, this is how you're going to do it. So you can see that BC from the original shape can be obtained from adding BD and that of, DC. So when you add, you're going to get, 21 plus 14, or in centimeters, and that will give you 35 centimeters. So it means the length BC is 35 centimeters. So the scale factor, which is denoted by the letter K, is equal to image length. So we have image length over object length. So this is the formula that we are going to use here. So now let's see something. This is the object, and that of this is the image. The question is which two sides or which pair is suitable to find the scale factor in this case. So that is obviously going to be, DC and that of BC. Those are the sides that can be used in this case because the two magnitudes are here. We can use them. Now, when you take the other ones, they can be used. But when you take EC, for example, and that of AC, the magnitudes are not given, so we can't use that. Now, when you take ED and that of AB, we can't also use that because AB is unknown. So the best pair to use is DC and that of BC. So now let's come to the scale factor here. So the length of image from here, I'm going to use BC. That's going to be BC out of the corresponding length of object, and the corresponding length is going to be DC. So we have DC here. So let's do the substitutions. BC is 35, that is this. So you have 35 here. Out of DC, that is 14. Can simplify this one. 7 can go into 14 2 times, and it goes into 35 5 times. So that means the scale factor is going to be 5 on 2. So that's the scale factor. Now let's use this idea or this scale factor to find the value of x in the next one. So let's get that here, and that's going to be II. We're going to find the value of x. Now this is x. Yeah, so to find the value of x, what do? You know that to get the image length, we just have to multiply the scale factor by the object length. So that is easily going to be this. AB, that is x, is equal to the scale factor, which is k, times ED or DE. Yeah, so you have to know this one. You should know that whenever you multiply the scale factor by the object length, we get the image length. And the scale factor is 5 on 2. So you just have to multiply by, ED, which is 18, and that will give us the value of AB, which is x. So let's do the cancellations right now. So 2 goes into itself 1 times. It goes into 18, 9. It means that we're going to get 5 times 9, and that will give us 45 centimeters. So it means x is equal to 45. Remember, AB is the same as x. So this implies that x is equal to 45 centimeters. So that is how we can find the value of x. Now, how do we find the area of triangle ABC? This is the triangle ABC, that's the image. So how do we find the area of this triangle? Remember in this question, the area of the triangle CDE was given to be, 78 centimeters squared. So that means the area of this triangle is 78 centimeters squared. So how do we use this one with the scale factor to find the, the area of the triangle ABC? That's the image. So let's get it right here. That's going to be I. We know that the scale factor in terms of area is going to be k squared. So that's the format that we're going to use here. So in terms of area, the scale factor is k squared equal to area of image over area of object. You have to know this formula as well. Now let's do substitutions. We know that k, which is the scale factor, is 5 on 2. So you're going to get 5 on 2 here. Remember, we are squaring that, so we have squared equal to this one. Now the area of image, that is what we are looking for. We can use a letter to represent that. So let me use the letter K for that. Out of the area of object, which was given in the question to be 78 centimeters squared. That's the area of the object. The object is CDE. So we just have to replace that here. So you have 78 centimeters squared here, which is just 78. Now at this point, we have to simplify the expression. Then we find the value of K. So this becomes normal or simple algebra. So now 5 on 2 squared is the same as 5 squared out of 2 squared, which is equal to K on 78. So 5 squared is going to be, so let me just get that one here. So 5 squared is going to be 25 out of 4, that is 2 squared, equal to K on 78. So at this point, we can do cross multiplication. Just 25 will multiply 25 and 4 will multiply K. So you can get that one here. So you have 25 times 78 equal to 4 times K. So what do? We have to divide here by 4. The whole of this side 2 by 4. So easily 4 will just cancel this 4 and we have K left. So K is equal to the whole of this stuff divided by 4. So let's simplify the numerator, and that's going to be 25 times 78. That will give us 1,550. Now divided by 4. When you do the cancellation, or when you use long division to simplify, we're going to get 487.5. Remember, that's the area, so it's going to be centimeters squared because the unit is meters, centimeters. So you have centimeters squared. So that's the area of the image, and that's the image ABC. Now let's get on this question. In the diagram, G1OH1 is an enlargement of triangle GOH with a scale factor K. So let's get, that one here, G1OH1 is an enlargement of this triangle. So that means this is the image. So we have the image here, and this is obviously going to be the object. So we have enlarged this triangle to get this triangle, and the scale factor is K. G1 is 9 centimeters. That is from this point to this point. So let me highlight that one here. So that is G1. That is 9 centimeters. Now GO is 3 centimeters. That is from this point to this point is 3 centimeters. We have 3 centimeters here. And G1H1 is 2 centimeters. G1H1 is 2 centimeters. Now you should remember that G1 is 9 centimeters. From this point to this point is 9 centimeters. But from this point to this point is also 3 centimeters. That means that moving from here to this point is going to be, 6 centimeters. Because the sum of these two should give us 9 centimeters. So that's what you're supposed to know. Now we're going to find the value of K. But before we do that, let's get something. This is the center of the enlargement. And whenever the center separates the image from the object, I want to say when the image and the object, they lie on opposite sides, then we have what we call negative dilation. In this case, it is an enlargement, so we have negative enlargement. So whenever we have a negative enlargement like this, now after finding the scale factor, we attach a negative sign to the scale factor. If you don't bring it, it means you're wrong. So whenever the object and the image lie on opposite side of the center, we attach a negative sign to the scale factor. So let's get that one here right now. Now we know that the scale factor K is equal to length of image over corresponding length of object. So which side am I going to use here right now? The best sides to use are G1O and that of GO. So I'm going to use G1O. So these two sides correspond to each other, and G1O is the image length and GO is the object length. Now straightforward we can do substitutions. G1O is 6 centimeters, so you have 6 centimeters here, and that is out of GO, which is 3 centimeters. We have 3 centimeters here. Now we do cancellations. So just centimeters to cancel centimeters. Now 3 here, 1, it goes into 6, 2 times. So that means K is equal to 2. But you should remember that they lie on opposite sides of the center. So we attach negative to this one. So the scale factor is -2. So let's get on this question. That's triangle MNP is an enlargement of the triangle NRS. Given that the line MP has magnitude of 15 and the magnitude of RS is 9 meters, that of NS is 15 meters, and PS is X. We have to find the scale factor, that is I, and II, we have to find the value of X. Now, this is how we can get the scale factor for this enlargement. Remember that we have two different triangles, triangle MNP, that is this one, MNP. So you can say that that's the bigger triangle. That's a bigger triangle. And then we have the triangle NRS, that's the smaller one, NRS. That's the smaller one. But we can see that they've all been merged as one. So the triangle NRS, which is the smaller one, is found in the the bigger triangle. So if you don't separate the two triangles, if you're not careful, you'll not be able to identify the the corresponding sides. And we know that when it comes to scale factor, we don't joke with corresponding sides. We make use of the corresponding sides. So that is why I've drawn the triangles here. So this is the bigger triangle, and that's the triangle PMN or MNP. They are all the same. I'm going to give this one here. So the P is here, M is going to be here, and here is N. So that's the triangle. Let's take the smaller one. So here's going to be S, that is this point. Here is R, and that of here is going to be N. So these are the vertices of the triangle. The next thing is to get the magnitudes. Let's start from the the smaller one. So from the the triangle, the smaller triangle, SN is 15. So that means here is going to be 15 meters. So we have 15 meters here. We have 9 meters for SR, so here's 9 meters. I think we don't have the NR, so I mean, we're going to write anything there. Let's come to the bigger one. When you take this one to, we have PM, that is this side, is 15 meters. We have 15 meters here, that is for the PM. When you take the other one to, we have PN to be this. I mean, we have to relax and talk about the PN. How do we get it PN? Let's say something. From the original diagram, if you want to get PN, it is the sum of PS that of what SN. So that means that PN, this one should be included in the solution. So that's why you're supposed to know. If you want to get the magnitude of Pn, we have to add x to 15. But Ps is x, and that of Sn is 15. So that's the magnitude. So it means this side is going to be x plus 15. So that's a binomial, so it should be kept in brackets. So we've been able to write all the sides. Now let's come to how to find the scale factor. So that is I. You know the scale factor, which is denoted by the letter K, is equal to length of image over corresponding length of object. Now these are the images that we're going to talk about, or the shape that we're going to use. Remember from the question, triangle MNP is an enlargement of triangle NRS. So this one, which is MNP, is an enlargement of this one. That means there was this triangle there before we got this one, meaning we've enlarged this triangle to get this one. So this is the image. So we have the image here, and this is the object. So you have to know the image and the object. Now we know that the scale factor is equal to the length of image over corresponding length of objects. We have to look for a suitable pair or sides that can be used to find the scale factor. And obviously, that's going to be the sides, PM out of, so PM is this side, which is 15, and it corresponds to SR of the object, that is this one. So we have SR here. Remember, we are using, the formula for finding the scale factor of an enlargement or reduction. The length of image over the corresponding length of object. You see, we didn't use PN and that of SN, because even though they are corresponding, but we didn't use them because PN is not complete. We don't know the value of X, so we can't use this one to find the scale factor. We didn't also use MN and that of RN because their magnitudes are missing. We don't know them. We don't know, MN. We don't also know RN. So we can't use this pair. I mean, that one is even out of bounds. We can't use that one here. So now let's go ahead and find the scale factor right now. So PM is 15 meters. We have 15 meters here out of SR, and SR from this is 9 meters. So you know that the meters will just cancel out. Scale factors don't have units. We can also simplify 15 and out of 9. 3 goes into 9 3 times, and it goes into 15 5 times. So that means the scale factor is going to be 5 on 3. So easily we have been able to find the scale factor of this enlargement. Now the next question, how do we find the value of X? That's going to be II. So let's get it under here. That is to find the value of X. This is X. S can be found from this, from this side Pn. And we know that Pn corresponds to Sn. So we're going to use the scale factor approach to find the value of X. So this time, since we want to find the value of X, we have to include, the side Pn and that of Sn, just trying to find the scale factor. So we know that the scale factor, in terms of this size, is going to be the length of image, and the image length is going to be Pn. So we have Pn here, out of the length of, the corresponding length of object. So that's going to be Sn for this one. Now, we can do substitutions here, but you should know that we know the scale factor already to be, 5.3. So I'll just have to do substitution. Where I see the scale factor, which is K, I'm just going to write 5 on 3 here. And that is equal to Pn, and Pn is X plus, 15. So that's parenthesis, it should be kept in bracket. Now, out of Sn is 15. That is just direct. We have 15 here. So at this point, we can do cross multiplication. So this one will just multiply, this one will multiply this one. So that is cross multiplication. Now let's do the cross multiplication. So let me do, this one here, 3 will multiply X plus 15, and that is equal to 15 times 5. I can decide to multiply this 3 by the terms in the bracket, but I don't want to do that because I've seen that 3 can go into, 15 here. So I just have to divide here by 3, here by 3, here 2 by 3. But if you want to multiply this 3 by x and that of 15, no problem, you're going to get the same answer. So this one will cancel this one. Now 3 goes into SF1, it goes into 15 5 times. So let me continue from here. So this implies that we have x plus 15 equal to 5 times 5. So we're going to get x plus 15 equal to 5 times 5 is 25. So if you want to find the value of x, we can subtract 15 from both sides, or simply we take 15 to the other side. So x is equal to 25 minus 15. So x is equal to 10. That is 25 minus 15. So that is how we can find the value of x. So that's the basic idea. You can rewind the video to watch it over and over to the best of your understanding.